How do pressure sensor transducers work? Imagine a tiny device that can tell you how much pressure is inside a pipe or a tank without even touching the liquid or gas. That's what pressure sensor transducers do. They turn physical pressure into an electrical signal that machines can read. These sensors have two main parts. One is the sensing element, which physically reacts to pressure. The other is the electronic system that converts this reaction into a usable electrical signal. The sensing element is often a thin, flexible diaphragm made of metal or plastic. When pressure from a liquid or gas pushes on it, the diaphragm bends or deflects. This movement changes some physical property, like resistance, capacitance, or inductance, depending on the sensor type. There are different types of pressure transducers used in electronics and embedded systems. One common type is the strain gauge or piezoresistive transducer. It uses tiny sensors bonded to the diaphragm. When the diaphragm bends, the strain gauges stretch or compress, changing their electrical resistance. This resistance change is detected by a circuit called a Wheatstone bridge, which turns it into a voltage signal. This type is popular for its accuracy and reliability. Another type is the capacitive transducer. It has two conductive plates separated by a small gap. One plate is attached to the diaphragm. When pressure causes the diaphragm to move, the distance between the plates changes. This change affects the capacitance, which is the ability to store electrical charge. The circuit then converts this change into an electrical signal. Capacitive sensors are known for being very sensitive and stable over a wide range of pressures and temperatures. Inductive transducers work on a different principle. They have a ferromagnetic core inside a coil. When pressure deflects the diaphragm, it moves the core. This movement changes the coil's inductance, which is how well it can store magnetic energy. The circuit detects this change and converts it into an electrical signal. These sensors are often used in industrial settings because they are tough and durable. Resonant wire transducers are another type. They have a wire attached to the diaphragm that vibrates at a certain frequency. When pressure pushes on the diaphragm, it changes the tension on the wire, shifting its resonant frequency. The circuit measures this frequency change to determine the pressure. The electrical signals from these sensors are usually very small. They need to be amplified and conditioned before they can be used. The output can be a voltage, a current like for to 20 milliamps, a frequency, or a digital signal. This output is then sent to controllers, displays, or data systems for monitoring or controlling processes. In simple terms, pressure sensor transducers work by translating a physical pressure into a change in an electrical property. The choice of sensor type depends on how precise the measurement needs to be, the pressure range, and the environment where it will be used. These sensors are essential in many fields, from controlling industrial machines to monitoring aircraft systems or medical devices. They help keep systems safe, efficient, and accurate by providing real-time pressure data.